Hi, everyone. I am super excited to be here and also very happy that I managed to forget my jackets at the dry cleaners. So I won't be losing any of them. But thank you very much, everyone. And thanks for Trent for having me be here. My name is Steve Crawford. I'm part of the Chief Science Data Office, part of the Science Mission Directorate. We work across the entire SMD to work on open science. My background is as an astronomer and having previously attended things like ADAS and worked on things like AstroPi, I'm really excited by this week's agenda and learning more about the planetary data community. I have a lot of stuff here, and so Trent, please just start waving at me when I'm way too getting close to time. But I really want to jump in to what we're kind of very excited about here at NASA. And one of the things is that the White House announced 2023 as a year of open science. This is a multi-agency initiative to spark change and inspire open science engagement throughout the US federal government. And one of the things that actually came out of this engagement and collaboration between different federal agencies is a common definition for open science across the US federal government. And it's the principle and practice of making research and products and processes available to all while respecting diverse cultures, maintaining security and privacy, and fostering collaborations, reproducibility, and equity. And open science is accessible, reproducible, and inclusive. We know that open science is a broad range of wide-ranging of different activities. Everything from sharing your publications to your data, to your software, but also how you build your teams, how you openly conduct your research. We know that open science creates research that is cited more, has a bigger impact, increases transparency, and is more inclusive. And when we have inclusive science, it means that projects are more collaborative, there's access to more hidden knowledge, more equitable systems, and increased participation. And there's already lots of amazing work being done already following these principles and practices. One of the great examples that I love to give is the first evidence of CO2 in exoplanet atmospheres from the James Webb Space Telescope. The project was part of the early release science program where the data became immediately open access as soon as it was available. But not only that, but because the team had access to open source software calibration that was developed, they could see how it was going to be done. They could plan how they're actually going to do their science, but they also built an incredibly inclusive environment. They built a Slack channel with over 400 participating scientists to take a look at this exciting early release data that was being produced by JWST. In their early proposals, and by having this more inclusive environment, they were able to actually work more quickly to actually compare results and to do it collaboratively rather than competitively. And they're able to produce early groundbreaking results detecting CO2 in the atmosphere of an exoplanet. One of the great things that they found is by working in these bigger groups, they're actually able to do more science. Their initial plan was to do 3 or 4 papers, and they currently have over 40 papers planned. But, this is one example. Open planetary science has been happening for almost 40 years. The PDS is a great example of open science with making the observations from the NASA missions and other observatories and opportunities available and public to everyone. But also in the last few years has been a great example of the planetary data ecosystem and the IRB report, which is a community developed report, which is made available to actually what in different ways about this much, much larger ecosystem beyond just the PDS of interacting with the data. And I love Open Planetary as an example of that, but there's also the open source software that's going on and so many other great examples. At the Chief Science Data Office, we work closely with a wide range of other members at NASA. Especially, I want to call out some of the other program officers at headquarters, like Becky Macaulay-Wrench, Megan Thompson, and Megan Ansell, along with a wide range of other people in the wider community in planetary science, talking about how to actually adopt some of these principles of open science more widely across the community. And one of the great things to actually announce, and Robin Ferguson is here. If Robin wants to say hello, she is a new planetary data officer, and she is located at Ames Research Center. And I know both Robin and I are excited to be here this week and also happy to have very opportunity to talk to everyone about what they're doing. And so and talk about all the exciting things which are happening at NASA. And I'm going to jump through and I'm going to go very quickly through all these exciting things and about what we're doing because of the wide range of things which are going on. And so NASA's Open Source Science Initiative is NASA's approach for putting open science into practice. It's part of the Chief Science Data Office with four main pillars for how we're actually doing this. One is policy and governance, implementing policies that advance open science, support SMD working groups and meetings, and developing standards and governance. Core data and computing services, developing SMD-wide data and compute infrastructures, and also providing the technology and infrastructure necessary for the implementation of SPD 41A. Open science initiatives, grants, cooperative agreements, prizes, and challenges that enable groundbreaking discoveries, and community engagement, advancing open science practices in the SMD community and building strategic partnerships. This is all based off of this didn't all start with the White House announcing a year of open science. It started actually probably almost about 9 years ago with actually developing community workshops and a range of different activities that developed the strategy for data management and computing that was released in 2019. And we've been trying to put this community development strategy into practice through the Open Source Science Initiative. Now I'm going to go very quickly through the examples here. There's a lot of material on my slides, but I want to actually highlight all the great stuff that's happening not only across NASA, but within the Planetary Science Division as well. And so with policy and governance, probably many of you have heard about SPD 41A, which is SMD's updated scientific information policy. We do include a wide range of different sources from workshops, communities, community town halls, the request for information that we put out for it, along with the White House Office of Science and Technology and Policy memo on ensuring free, immediate, and equitable access to federally funded researchers. To provide the highlights for SPD 41A, it's the updated policy, and I want to really emphasize the updated policy is forward-looking. We're looking to apply this in new grants and new policies and new missions. Peer-reviewed publications are made openly available with no embargo period. Research data and software are shared at the time of publication or at the end of the funding award. Mission data are released as soon as possible, and unrestricted mission software is developed openly, and science workshops and meetings are held openly to enable broad participation. We know these things are going to make our science more reproducible, more accessible, and more inclusive by making that information more available and more widely available. The SPD 41A requirements have started to become included in ROSES 23, including an open science and data management plan, which is a space and area for you as you're submitting proposals to NASA to explain how you'll be implementing the guidance, which is in SPD 41A. We've also had put out a document on SMD open science guidelines, which actually really walk you through. I would actually never suggest anyone reading SPD 41A. As a scientist, I wouldn't actually ever suggest that to anyone. But we have put out this document called SMD Open Science Guidelines, which we're developing openly on GitHub. So to take a look at it, if there's things missing, it really steps you through what you need to do and what different things you need to do. The great thing is, not only that, but the Planetary Information and Data Management Policy was put out by PSD as well to actually help you further guide through it. SPD 41A applies to everyone. So there is parts where it's intentionally vague because what happens in Earth science versus what happens in astrophysics, what happens in planetary data are all different. And so each division also put out their further guidance to really help explain and step through where are the areas which you should really be thinking about as planetary scientists. And so there is a lot more detail and a lot more help, which is in here as well. But I want to jump through into some of the things that we're actually doing to help actually implement these policies and make your life easier as scientists and engineers to actually really make what you're doing openly and accessible. And so one of the main things right now is looking at the Core Data and Computing Services program. We're hoping to actually release a report on this at the end of August, which actually looks at how we can actually develop both our high-end computing and our cloud computing to really enable open science and what technology we need to further develop to actually fully implement the policies within SPD 41A. But some of these we are already putting in practice to actually make your lives easier. I believe Emily Fauci is talking after my talk about the Science Discovery Engine, which is actually making data discoverable across SMD. So I'm gonna let her talk more about the SDE. We've also expanded the Astrophysics Data Service. If for those who are already familiar with ADS, you probably have been using this for quite some time. For those who aren't familiar with it, it is a great service for actually discovering publications. Being able to actually search through and link both publications to data It has been an invaluable service to the astronomy community for the last 30 years. We've expanded this to planetary and heliophysics. They already think they're covering about 90% of the known publications within those fields. And it's actually going to be expanded to earth science and biological and physical science as well to cover all of NASA SMD. And be released later this year as the Science Explorer when it's ready. But ADS itself, you can already go to it and actually search, and already includes a lot, or at least a majority of the publications within planetary science. A great thing, and I think there's a further talk on this later at the conference as well, is supporting public cloud data, and that the USGS has created a number of cloud-ready data sets that are hosted on the AWS Public Data Registry. And so we're actually supporting groups moving to the cloud to actually make it easier to more widely share your data, especially these big data sets that you can no longer download onto your individual laptop to make available to everyone. But we're also incentivizing open science. We're not just, this is not an unfunded mandate. We're actually providing the funding for it, including directly to open science tools. And in addition, in your budgets and other aspects, when you submit your proposals, should include the requirements and costs to make these things openly available. But we are trying to actually support a wide range of open science tools as well. We have a number of initiatives which are actually supporting open source software libraries, which a wide range of them here, like NumPy, Pandas, Julia, and along with the AIM stereo pipeline. And so I see Ross in the back there. He's one of our PIs within the open source tools, frameworks, and libraries program. And so we're really happy to be actually supporting a wide range of different open source programs, which are actually being supported from NASA. We also have a range of grants. So these are actually here for those who are doing open science, working on making your data sets more publicly available, working on actually making things more open and available. We do support open science topical workshops, symposium, and conferences, but our particular ones are supporting the open source tools, frameworks, and libraries, which is the one I just mentioned. We also have a supplement for open source software awards. If you have software that you'd like to make openly available and currently have a NASA grant, we have a supplement to actually help support that. We also have the high priority open source science awards. Both F8 and F15 are usually open rolling deadline awards to actually wildly help support open science. And so these are actually basically the high priority open source science awards are small grants to actually act as seed funding for open science projects that you may be carrying out. So these don't actually require any specific scientific question, but actually just focusing on doing open science for your field as well. And also for those who are interested, PSD is also returning to PDART in ROSES 23 with the T is restored, and proposals for software and tools are once again accepted to PDART. They're also going to be looking at ways that provide support for long-term maintenance of software tools, and also a range of different conferences as well. Ones which are focused on workshops or conferences should also still be supported to the TWISP call, and can be supported either from PSD or from the CSTO. We also support data challenges. And so here are two examples of data challenges. These actually worked with, one was with Topcoder, one was with Driven Data to create public data challenges based on available NASA data. One was the NASA SOHO Comet Challenge, discovering comets within the SOHO Solar Explorer data set. The other was looking at how to improve mass spectroscopy for use on Mars. These actually end up having thousands of people looking at NASA data and taking their best set of tools and ways to actually improve detection and discoverability in these data. We really love supporting these to actually make them more widely available and accessible to a much, much wider community. We'll have more which are actually be coming up later this year. But I've been running through a lot of stuff, and a lot of this may be new to a lot of people. Maybe for a lot of people in here, you're actually very familiar with a lot of the different aspects, and you've been working on open science for a long time. But we also know that open science is also new to a lot of people. And there's also open science is a wide range of different things, which maybe actually some of it you might be very familiar with, but other parts of it not. And so to help out, we're actually introducing a new initiative called NASA's Transform to Open Science, which is a 5-year mission to accelerate adoption of open science. Its goals are to increase understanding and adoption of open science principles and techniques, broaden participation by historically excluded communities, and accelerate major science discoveries. And it has 4 areas it's focused on in terms of engagement, capacity sharing, incentives, and coordination. And one of the main parts of the TOPS program is building community, and participation is a fundamental part of an open scientific process of listening, learning, collaborating, and engagement. And so there's a wide range of different ways to engage with the TOPS community, from online discussions, monthly newsletters, websites, conferences, events, resources. And if you actually, one of the things we also love doing is hosting your open science success stories. And so if you have stuff where you're being and succeeding as open science, we'd love to actually host your host your stories as well. And one of the things that we are doing as part of this is developing an Open Science 101 curriculum. It's a community-developed introduction to open science with inclusivity, accessibility, and diversity at the forefront, designed to provide researchers with core open science skills, for example, how to write data software management plans, knowing about open science tools and best practices, for example, ORCID, and growing connections across the community of open science practitioners. We currently have enrollment now and expect to be actually releasing the curriculum in July, actually next month. And so the curriculum includes 5 main modules, which are actually designed to introduce open science. The first is the ethos of open science, the what and why of how I should be doing it. Open tools and resources, how to use popular open science tools, how to use, make, and share software, how to use, make, and share open data, and then best practices for sharing all results and analysis, as well as peer reviewing. After completing all 5 courses, you can receive an open science badge. There'll be a range of different options for how to complete it, including in-person workshops, online and virtual training, also along with an online MOOC. For those who are actually very familiar and experts already in open science, there'll be ways to actually fast pass out of it, so you can actually take it and still get the badge for it. But you may actually still be interested in taking parts of the course to actually learn something new as well. There's always actually something different and something new happening in open science. Perfect. And one of the things, so we're also building on Open Science 101, and we actually just supported through our TOPS training grants, is there'll also be the science core as well. OS 101 provides a wide spectrum of open science training, but we know that actually in every division, every group, there's a lot more to actually learn, especially specific to your community. One of the grants that I'm actually most excited for was awarded to Sierra Brown on Knowing the Sky, Building Open Science Skills Through Native Knowledge Practices, which is one of our top science core programs, which is particularly focused on planetary science. And so we're actually really excited both for the curriculum that'll be coming out, along with the science core, which actually introduced much further skills in terms of, and wider skills in terms of how to actually further advance your science. And so there's a range of different incentives. I've mentioned some of the awards, the badges, and the prizes and challenges, but we're also trying to grow recognition for open science and open science practitioners, and also introduce more and open science into actually evaluations as well. So part of future ROSES evaluations, for example, will include the assessment of your open science and data management plan. And so wanted to actually go through and give you all the highlights because I know there's a lot going on, and I know that went very, very quickly. But we're really excited about the Open Source Science Initiative, but we're also really excited about what's being done here in the planetary science community. OSSI is supposed to be a top, even though OSSI is a very, at times, a very top-heavy activity, it's really built on all the work and elevating the voices and work being done by the community here. And so I want to say thank you for letting me talk, but really thank you for all the work that you're doing. You can learn more about OSSI along with all the different works, signing up for the TOPS enrollment and other activities at the link. And so really looking forward to hearing all of your talks and information this week as well. Thank you very much.
Thank you. So We don't have time for questions just now, but we do have time after this initial session. We'll have about 10 or 15 minutes of time before the break. Thank you, Steve. And we'll bring up the next speaker.